Alright guys, this is the marking period 2 post-assessment review. Go through this pretty quickly. So polynomial has these zeros, which is the minimum degree. So all we have to find is degree. We don't have to find the actual polynomial. So when we rewrite these, a couple things we have to remember. With radicals, we're going to also get here the negative, the conjugate. Right? Then we write x equals -3, x equals 5, x equals 6i, and then the conjugate of this, x equals -6i. Right? So from here, we then write all of these as factors. So x, bring this over, minus radical 2. X, bring that over, plus radical 2. X plus 3, so it's all the opposites. It's -5, same thing happens here. Right now, what we have done in class many times, we would distribute all of this and come up with a pretty long polynomial. Here they're only asking for the degree. So x times x times x times x times x times x is x to the 6th. So what's the minimum degree? A degree of 6. Right? F of g of 3. Start inside out. G of 3 is equal to 3 plus 2. Right? Substitute it in. This gives me 5. Now we do f of 5. 3 times 5 minus 1. 15 minus 1 is 14. So f of equals 14. Okay, moving on. How many solutions does this have? So we have to solve this. X plus 2 equals radical 8x plus 1. Square both sides to get rid of the radical. When we square this, we write it 2 times. This cancels with the radical. Right? We distribute here. We get x squared plus 4x plus 4 equals 8x plus 1. Bring everything to the other side. Minus 8x minus 1. Right, so we get here is x squared minus 4x, not 5, 4x. 4x plus 3 equals 0. Factors of 3 that add up to 4, x minus 3, x minus 1, all equals 0. Alright, solve this. X equals 3, x equals 1. Let's check now. X equals 3. Check this out. So 3 plus 2, I'm substituting it back into the original. 3 plus 2 is equal to radical 8 times 3 plus 1. This is just 5. 8 times 3 is 24. 24 plus 1 is 25. Does that work? Yes, it does. So this is a solution. Let's test x equals 1 now. So 1 plus 2 is equal to radical 8 times 1 plus 1. That's 8 plus 1, which is 9. So radical 9 equals 3. Does it? Yes, it does. How many solutions do we have? 1, 2. 2 solutions. Identify the leading coefficient, degree, and type. Alright, so leading coefficient here, -3. Degree, the largest degree here is a 4. Type, because the degree is 4, that's called a quartic function. So it's a quartic. Alright. Quadratic would be 2. Linear would be 1. Cubic would be 3. Quintic would be 5. Okay, moving on. Alright, explain the steps simplifying the following by hand, meaning you wouldn't use a calculator, you just do this by hand. So the first is write with square root. Alright, so the 1/2 becomes just the square root of 4 over 9. Alright. And we take square root of the numerator and denominator. So square root of 4 over square root of 9. Lastly, we simplify. Square root of 4 is 2, square root of 9 is 3. Now, it doesn't tell you asked to write all of this, but I really think it makes it much easier if you do the work as you go. Alright, so we just have 3 short steps right there. Alright, provide an example in real life where you would see rational functions. Rational functions mean ratios, right? It means fractions. Right? We really haven't talked about it too much, but an example would be comparing the time to complete a job, which means work, some type of work, mowing the lawn, painting, anything, versus completing the job. I'm going to say work here, work, completing the work with multiple people. Multiple people. Alright. It takes one person 5 hours. It takes 5 people a lot less than 5 hours. Alright, divide. So when we do this, we have to keep the numerators here in the first fraction. Multiply, change to multiplication, and take the reciprocal of the second one. Right, now, the rest is just factoring. Factor, factor, factor. Make sure we factor everything. So up here, what's in common? X to the third is in common. Right, so we get x squared minus 4. I can keep going. That's the difference of squares. X plus 2 and x minus 2. Alright. That's all going to be over. Factor this. Factors of 2 that subtract to give me a 1. X minus 2, x plus 1. Right? So this became that. This became that. Okay. Moving on. We make one big fraction. We factor this. Difference of squares. X plus 1, x minus 1. Okay. And we factor this. What's in common? And x to the third is in common. I'm going to bring that x to the third out here. Right? So here what we get left over is x squared minus x minus 2. That was the same as this, so it's going to factor the same way here. X minus 2, x plus 1. Right? What do we see the same of? Right, this is going to cancel with this. Do we have any x plus 2's? No, we do have an x minus 2. We have an x plus 1. And that's it. So what we have now is x plus 2 times x minus 1 all over x minus 2 times x plus 1. Last step is just to distribute. So we get x squared plus x minus 2 all over x squared minus x minus 2. Alright, moving on. So here it says the factor theorem. Determine whether the given binomial are factors. Alright, this is pretty simple. When we synthetically divide, synthetic division, right, we need to see if the remainder equals 0 or not. So, opposite of that, negative 1. 3, 4, negative 7. Bring this down. So 3. 1 times 3 is negative 3. That gives me 1. That gives me negative 1, negative 8. So since the remainder is not 0, x plus 1 is not a factor of p of x. Right, so that's the next one. So now instead of negative 1, the opposite here was 1. 3, 4, negative 7. Bring this guy down. 3. Multiply, we get 3. That gives me 7. 1 times 7 is 7. 0. Now look what happens. So since, let me just say the opposite. Since the remainder is 0, x minus 1 is a factor. Okay, let's keep going. So in this one, first I want to split this up. So the fifth root of x to the 25, y to the fifth, over the fifth root of 32. When we're taking the root of variables, just divide. 25 divided by 5 is 5. 5 divided by 5 is 1. 50 with 32 is just 2. Why has this happened? Let's see. 16 and 2. Keep going here. 8 and 2. 4 and 2. 2 and 2. 1, 2, 3, 4, 5. There's 5 of them, so it's just 2. All right? F plus g, so rational functions. I'm going to factor this as I go. So I'm going to factor this here. X squared minus 9 is x plus 3, x minus 3, plus the g is already factored, x minus 3. Now, if we look down here, what's in common? In common is an x minus 3. Left over is an x plus 3. Right? So on this side, I need nothing. However, on this side, I need to include an x plus 3, because that's what's missing. Right? We can distribute this. This is going to become x squared plus 3x. Right. So then x squared, 3x and x is 2x minus 2. Oh, sorry, 3x and x is 4x. Oh boy. 4x. And then minus that 2. We can't factor that, so I'll put this back together. X squared minus 9. H minus f, very similar here. So h, x over x now plus 3. Minus f is, I'm going to use the factored form again. Right, same idea on this side, we need to include the other x minus 3. Make sure we distribute this negative. That's why I'm going to put parentheses here. Right? So we're going to get is x squared minus x when I distribute this, minus 3x, minus x plus 2 when I distribute this. That gives me x squared minus 4x plus 2. Cannot factor. X squared minus 9 goes here. All right. Last but not least, we can do one like this, but it's not difficult. 10x over x minus 2 is equal to 9x plus 4 over x minus 2. Okay. From here we cross multiply. Watch. 10x times x minus 2 equals this times this. The bell might ring in a minute, so make it loud. Distribute. Distribute here, 9x squared minus 18x plus 4 minus 8. 4x. Okay? Combine terms. 9x squared minus 14x minus 8. I'm going to bring all of this to the other side. Okay, so what I get is x squared. I'm going to bring this over to there. I'm going to add it and get minus 6x. Bring this over to here and get plus 8, all equal to 0. We factor. Factors of 8 that add up to 6, 4 and 2, minus and minus. So what we get here is x is equal to 4 and x is equal to positive 2. Right? Any questions, guys? Just email me. Best of luck on the test tomorrow.